Hi, this is Divya Krishna. In this video, I'm going to demonstrate a data mining exercise using SAS Enterprise Miner tool and also explain few important concepts of data mining. So this is our data set which has been downloaded from the UCI repository. So our data set name is glass identification. Our aim is to predict whether the glass is a float type or not based on all these 10 attributes. So this is the interface of SAS Enterprise Miner. As SAS Enterprise is run on a cloud server, I've already imported all the nodes and run them. I've imported all these nodes by dragging them from this tab and dropping them here. The first node is file import node, which is used to import the file. The file can be imported by clicking on this import option file here. Click on OK. By right clicking on this file import node, we can edit the variables. As our aim is to predict the type of glass, I've set this as target and the level is nominal. The next node is stat explore node, which is used to calculate the mean, median and mode of the dataset. The next node is the data partition node. By using this data partition node, we can divide the data into training, validation and test. So I'm giving 70% of the data for training and 15% for validation and 15% for test. The next node is the control point node, which acts as a single point of contact between all the models. The next node is decision tree node. Let's run this model now. By right clicking on the node and clicking on run, the results are here. Let's see the results. So this is our decision tree, which is split by using barium first and then potassium. And then magnesium and aluminium. So this is the output of our decision tree. So these are the false positive, true negative, false positive and true positive for the training and validation data set. So now I'm going to explain the first concept. If the number of true positive and true negatives are more, then the model built is said to be a good one. The second concept which I'm explaining now is splitting. Splitting is the heart of the decision tree algorithm. In splitting, the data is divided into several nodes. To get better accurate results, every child node must be good. So we can do the splitting in the SAS Enterprise Miner by editing the values here in the splitting rule. The third concept which I'm going to explain in this video is pruning. Pruning is the technique that reduces the size of the decision tree and hence improves the predictive accuracy by reduction of overfitting. Now I'm going to prune this data set. I'm increasing this maximum depth to 10, which means that the training data will include 10 generations of the root node. I'm increasing this leaf size to 8 to ensure that each leaf contains 8 observations and the number of surrogate rules to 4. Now this decision tree is pruned and now let's run the results of this decision tree. The results are here, and if you look at the decision tree, the tree is pruned now as the size of the tree is reduced. The next concept which I'm going to explain here is entropy. Entropy is the measure of disorder of the child node. Entropy is given by the formula minus P log P. Entropy can be calculated in the data set. Entropy can be calculated in this data set by selecting this entropy or Gini option in the ordinal target criterion in the properties. I've also imported the neural network node here. Let's check the output of this neural network node. The results of neural network model are here. If we click on results, this is the output of neural network model. The mean is calculated for training, test and validation datasets in this neural network model. Let's go back to the model now. The fifth concept which I'm going to explain in this video is the backpropagation in neural network. Backpropagation technique is a method of training artificial neural networks along with an optimization method. So now let's see how backpropagation can be done in this SAS Enterprise Miner. Go to properties and click on the tab here beside optimization. Here, the training technique can be changed to any of these here. As we are discussing about backpropagation, let's click on backpropagation. The results of the neural network after training the dataset with backpropagation algorithm are here. If we compare the false negative, true negative, false positive and true negative values, of the default and backpropagation training methods, they're almost found to be same and for this data set. Now let's compare both the models by using this model comparison node. The results of this model comparison are here. Let's check them. So this is the output. So let's see the misclassification rate. The misclassification rate for neural network is 0.406, and whereas for decision tree the misclassification rate is 0.593. As the misclassification rate is low for this neural network, it is considered to be the best model for this dataset. Thank you for watching this video.